Have you ever gazed up at the night sky and felt a sense of wonder, a longing to visit those distant, shimmering stars? But then reality hits. Even the closest star, Proxima Centauri, is over 4 light-years away. With our current technology, a journey there would take tens of thousands of years. It's a cosmic speed limit imposed by the universe itself, dictated by Einstein's theory of relativity. Nothing with mass can travel at or faster than the speed of light. But what if? What if we could break that rule? What if we could travel faster than light? This isn't just a fantasy from our favorite sci-fi shows. It's a question that has captivated scientists and dreamers for generations. Imagine hopping from one galaxy to another in the time it takes to brew a cup of coffee. The implications would be staggering, completely reshaping our understanding of the universe and our place within it. So, let's buckle up and embark on a speculative journey. Let's explore the mind-bending possibilities and profound paradoxes of faster-than-light, or FTL, travel. First, let's understand the cosmic roadblock. Albert Einstein's theory of special relativity tells us that as an object with mass accelerates, its mass increases. As it approaches the speed of light, its mass approaches infinity. To push an infinitely massive object, you'd need an infinite amount of energy. It's the universe's way of saying, nice try, but no. This is why spaceships, astronauts, and even tiny particles are all stuck in the cosmic slow lane. But human ingenuity loves a good challenge, right? Physicists have been cooking up some clever workarounds that don't technically break Einstein's laws but bend them in very interesting ways. One of the most famous ideas is the Alcubierre drive, proposed by physicist Miguel Alcubierre in 1994. Picture this. Instead of moving your ship through space, you move space around your ship. The Alcubierre drive works by creating a warp bubble of spacetime. It would compress the space in front of the ship and expand the space behind it. Inside this bubble, the ship itself would remain perfectly still, not violating any laws of physics. It would be like a surfer riding a wave, except the wave is the fabric of spacetime itself. From the perspective of someone outside the bubble, the ship would appear to be moving faster than light, potentially covering vast interstellar distances in mere days or weeks. Sounds amazing, doesn't it? A real-life Starship Enterprise. However, there's a tiny catch. To create this warp bubble, you'd need something called exotic matter. This isn't just matter that's rare or hard to find. It's matter with negative mass or negative energy density. We've observed effects similar to this on a quantum scale, like the Casimir effect, but we have absolutely no idea how to create or control a stable chunk of exotic matter large enough to power a starship. It's a colossal engineering hurdle that might be fundamentally impossible. Another fascinating concept is the wormhole, also known as an Einstein-Rosen bridge. Imagine spacetime as a giant sheet of paper. To get from one point to another, you'd normally travel across the surface. But what if you could fold the paper and poke a hole through it, creating a shortcut? That's a wormhole. It's a theoretical tunnel through spacetime that could connect two very distant points, potentially light-years or even galaxies apart. You could enter one end of the wormhole and pop out the other almost instantly, effectively traveling faster than light without ever locally exceeding the speed limit. Sci-fi loves wormholes for this exact reason. The problem? According to our current understanding, naturally occurring wormholes, if they exist at all, would likely be microscopically small and incredibly unstable. They would collapse in an instant, long before you could even send a message through, let alone a spaceship. To keep a wormhole open and traversable, you'd once again need a healthy dose of that elusive exotic matter to prop it open. It seems we keep running into the same roadblock. But let's suspend our disbelief for a moment. Let's assume we solve the exotic matter problem. We build our warp drive ship or stabilize our wormhole network. Humanity becomes an interstellar species. What would that world look like? The first and most obvious change would be the end of cosmic isolation. Our solar system would become just a tiny neighborhood in a vast, accessible city of stars. We could finally answer one of the most profound questions of all time. Are we alone? We could visit exoplanets like TRAPPIST-1e or Kepler-186f, worlds that we suspect might harbor life. We wouldn't have to rely on faint signals or blurry telescope images. We could send probes or even people to walk on alien soil, to breathe alien air, well, with a helmet probably, and to see if life has taken root elsewhere in the cosmos. The discovery of even simple microbial life on another planet would be one of the most significant moments in human history. Exploration would lead to colonization. Humanity could spread out among the stars, creating new homes on new worlds. This wouldn't just be an adventure, it could be a survival strategy. Having humanity on multiple planets would be the ultimate insurance policy against a catastrophe that might wipe out life on Earth. Whether it's an asteroid impact, a supervolcano, or something of our own making, we would become a truly resilient, multiplanetary species. The economic implications would be just as massive. Imagine interstellar trade routes. Resources that are rare on Earth might be abundant on another planet. We could mine asteroids and other star systems for precious metals or harness energy from more powerful stars. This could lead to an era of unprecedented prosperity and technological advancement, a new gold rush on a galactic scale. New industries, new technologies, and new cultures would spring up around this new interstellar economy. However, faster-than-light travel isn't all sunshine and star-hopping. It comes with a set of deeply unsettling paradoxes, particularly concerning time. According to relativity, time is not absolute. How fast time passes for you depends on how fast you're moving. This leads to the famous twin paradox. If one twin stays on Earth while the other travels near the speed of light, the traveling twin will age slower. But with FTL, things get even weirder. Traveling faster than light could be mathematically equivalent to traveling backward in time. Imagine sending a message to a star system 10 light-years away using an FTL signal that arrives in just 1 year. From the perspective of the people receiving the message, they could send a reply, also via FTL, that arrives back on Earth before you even sent the original message. This breaks the fundamental principle of causality, the idea that a cause must always happen before its effect. You could receive a reply to a question you haven't asked yet. You could learn the outcome of a race before it has even started. This opens the door to all sorts of logical nightmares, like the infamous grandfather paradox. What happens if you go back in time and prevent your own grandparents from meeting? You would never have been born to go back in time in the first place. It creates a loop that makes no logical sense. Some physicists believe that the universe has built-in protection against these paradoxes. Perhaps any attempt to travel back in time would fail, or perhaps it would create a new, parallel timeline, leaving the original timeline untouched. But we simply don't know. The ability to manipulate causality could unravel the very fabric of reality as we understand it. It's a power that might be too dangerous for anyone to wield. So, where does that leave us? Is faster-than-light travel an inevitable destiny for humanity, or a forbidden fruit we're not meant to taste? Right now, it remains firmly in the realm of theoretical physics and science fiction. The hurdles, like creating and controlling exotic matter, are so immense that they may well be impossible to overcome. But we should never say never. 150 years ago, the idea of flying in a metal tube across the ocean or talking to someone on the other side of the world instantly would have seemed like magic. Scientific breakthroughs often come from challenging what we think is possible. Perhaps a future Einstein will discover a new principle of physics that opens the door to the stars. Perhaps our quest for FTL travel will lead to other incredible discoveries we can't even imagine yet. The dream of interstellar travel is a powerful motivator. It pushes us to look beyond our own small world, to explore the unknown, and to expand the boundaries of our knowledge. Even if we never build a warp drive, The pursuit of that dream fuels the science that helps us better understand our universe. For now, we'll continue to look up at the stars, not as unreachable points of light, but as future destinations, waiting for us in the vast, beautiful, and mysterious cosmos. Thank you so much for joining me on this journey through space and time. What do you think? Is FTL travel a future reality or an impossible dream? Let me know your thoughts in the comments below. And if you enjoyed this cosmic adventure, don't forget to like, subscribe, and hit that notification bell for more explorations into the wonders of our universe. See you next time.